Hello everybody, my name is Abdullah Alsenawi.
My name is Siuffo.
And my name is Ojairi.
This is class Mechanical Design 2. Today we're going to present Project 2 Gearbox Design. Main purpose of this design is to design gearbox that is capable of transmitting 4.5 horsepower between maximum input shaft and output shaft speed. Input shaft speed is set to be 600 revolution per minute and output shaft speed is set to be 40 revolution per minute. Size of the system must be designed to be easily assembled to any system that is required given specifications. Input and output shaft in the system are to be perpendicular to each other. Rotation of the output shaft is to be in the same direction as the input or opposite. Gearbox specifications: the transmitted horsepower is to be 4.5 horsepower. The input shaft speed is 600 RPM and output shaft speed is 40 RPM. Ratio is 15:1. The direction of the shafts are the same. Precision is medium to low. Shock tab moderate. Environment humidity is 90 to 95%. Operation temperature more or less 50 Fahrenheit. Our conceptual design is a worm gear speed reducer, as is shown in here. We chose worm gear reducer because it only needs low input to moderate horsepower. Initial costs of worm gears are mostly low. Worm gears are smoothest, quietest form of gearing. It requires minimal space to operate and got high tolerance for shock loading.
Okay, so the applications for this type of low-power gearbox are food processing machines, warehouse material handling, conveyors, packaging machinery, and other machinery. So the design process for this gear is: step 1, specify initial parameters such as gear ratio, transmitted power, design factor, and the materials to be used. Step 2 is to use the Ogham equations to calculate the design variables, such as the actual pitch of the worm, the pitch diameter of the worm, the face width of the gear, and the dimensions of the gear case. Step 3 is to use the manufacturer's catalog to specify the correct parts. And finally, step 4 is to do the design in AutoCAD using a software. So these are final design. As you can see, we have the gearbox and these are the internal components.
Alright, so now I'm going to talk about the cost analysis. Looking at each unit cost or unit price, the estimated cost of gearbox will be around $150 to $200. For the maintenance, our gearbox should be kept in an optimum operating condition so that the facility can operate at its most efficient. One of the most important steps to increase the gearbox life is to keep it properly lubricated. We highly recommend using synthetic lubrication because due to the vast ambient temperature range, synthetic oil is a great choice because of its high viscosity temperature. We chose a worm gear speed reducer because the initial cost of the system is more important than efficiency. In an application where high efficiency is required, a better solution would be probably to use a helical bevel gear reducer. In conclusion, many manufacturers of helical-based gearing misled engineers to believe that the worm gears are incapable of running efficiencies of 90% and higher. In this figure, it shows that worm gears are capable of running efficiencies of 90% or higher, and ratios below 20 to 1. Our design speed ratio of 15:1 will still give you an efficiency of more than 90%, which is still considered good because of our given specifications. Thank you very much.
We didn't talk about vibrations.